Okay, so we've seen what the distance formula is, but where does it come from? It all points back to the Pythagorean theorem, a squared plus b squared equals c squared. If you remember, when you have a triangle with a right angle, you can find the longest side, called the hypotenuse, by plugging in the side lengths for a and b. For this triangle, a and b are 3 and 4, and after you solve it all the way out, you get 5 for the length of the hypotenuse. Let's pause right there though and see what's happening. If you notice, at the very end we took the square root of 25. Let's keep that square root symbol, but let's back 25 up to how we originally got it. We had 3 squared plus 4 squared, and we figured out that equals 25. Therefore, we can rewrite our equation as the square root of 3 squared plus 4 squared, because this means the same thing as the square root of 25. This is exactly what the distance formula is doing. It's skipping the solving process and just putting the a squared plus b squared under the square root symbol. Check it out on a graph. We have a segment which is the same as the hypotenuse from the triangle earlier. Then we can draw the two legs of the right triangle. And what do you know? Their lengths are 3 and 4 just like we saw earlier. We have the same exact triangle, but now it's just on a graph. But where does the x2 minus x1 and y2 minus y1 come from? This is just a way to always get the lengths of the two sides of the triangle. When you subtract the two x values, you get 3, and when you subtract the two y values, you get 4. Those are the same lengths of the triangle again. This will work no matter how long the sides are because you're just subtracting the highest and lowest numbers that the segment reaches to. Therefore, to conclude, the distance formula and the Pythagorean theorem are basically the same thing. The Pythagorean theorem uses a squared plus b squared, and the distance formula rewrites the a and b by subtracting coordinates to find the lengths.